Hello, my name is Caitlin, and I'm a chemical engineer at Yellowtree. Towards the end of 2019, the Botswana Bureau of Standards, known as BOBS, released a standard titled Air Emissions from Stationary Sources. In this video, we're going to review this standard, compare it with South Africa's air emissions legislation, and we're going to highlight a few questions that arise from the standard. This is what the cover page of the standard looks like, and not being familiar with Botswanan standards myself, this cover page did raise a number of questions for me. The first one was, what is BOBS? According to their website, BOBS is a parastatal, promotes standardization and quality assurance activities, and is a full member of ISO. The next question I had is, what is a standard? According to the BOBS website, a standard is a document which is established by consensus. It's approved by a recognized body, in this case ISO. It provides rules and guidelines for common and repeated use. It aims to achieve order, and it can be similar or identical to international or foreign standards. This is something we're going to want to keep in mind, as we will see a number of similarities between this Botswanan standard and the South African air quality legislation. As we know, this particular standard concerns air emissions from stationary, non-mobile sources. That means that it'll be applicable to, for example, a chimney stack, which doesn't move, but it won't be applicable to a truck, which moves and is mobile. And we also know that this particular standard was developed by BOBS in consultation with the Department of Waste Management and Pollution Control in Botswana, with input from industry bodies from industries like mines, power, and meat, with input from consultants, and with input from the University of Botswana. Knowing all of this, I'm still left with a question, and that is, what is the legal status of a BOBS standard? Is it merely a guideline for best practice operation, or are there legal imperatives to comply with the provisions in the standard, and are there sanctions for non-compliance? This is a question that I hope to address when I'm able to engage with someone who created the standard. I'm now briefly going to go through each of the sections in the standard, and I'm going to highlight the most important aspects from each section. Section 1 deals with the scope of the standard. As we already know, the standard specifies air emissions limits for stationary sources, and it's applicable to any facility, site, or premises whose activities result in air pollution. It's not applicable, however, to mobile sources, as we've already discussed, or to residential premises. Section 2 addresses the normative references, that is, references which are indispensable to the application of the standard. These documents include ISO 17025, which is the ISO standard for laboratories and is the ISO standard which is soon to be required by all stack emissions testing companies in South Africa. Also indispensable to the standard is the Waste Management Act of Botswana. Section 3 gives definitions of words and phrases which are used in the standard, and the most relevant ones to us as stack testers are as follows. This standard defines normal cubic meters as cubic meters at conditions of 0 degrees Celsius and 1 atmosphere, which is the same as 101.3 kilopascals. These are the same conditions which are required in the South African legislation. The standard refers to a technical signatory as a person who approves laboratory test results, and it notes that this person must hold the ISO 17025 qualification, and this is a great addition to the standard because this requirement increases the likelihood of results being good and accurate. Also interesting is the definition of VOCs, which is always very interesting because VOCs can be defined in a number of different ways. In this case, VOCs are defined as a group of carbon-based compounds with a high enough vapor pressure under normal conditions to vaporize and enter the atmosphere. Let's move on to section 4, which talks about the general provisions of the standard. Firstly, results are required to be reported as a daily average and as discussed at conditions of 273 Kelvin, which is 0 degrees Celsius, and 101.3 kilopascals. It's also specified that pollutants must be reported at dry conditions, which is standard when reporting air pollutants. Interestingly, the standard requires that emissions be reported at atmospheric oxygen, which is 21%, and we could thus also say that the results must be reported with no oxygen reference. And this is a particularly interesting provision. Oxygen references are used to reverse the effect of the dilution of pollutants by ambient air. They can only be used for combustion installations where oxygen is consumed as part of the combustion reaction. One applies an oxygen reference by multiplying the emissions measured by the formula shown. The oxygen reference is usually specified to be a value which is typical for the fuel burned or for the type of combustion installation. If we use coal-fired boilers as an example, an oxygen concentration of 10% is typical, and so 10% is usually specified as the oxygen reference for coal-fired boilers. Additional dilution air could be added to the system in one of two ways. Firstly, ambient air could enter downstream of the boiler, either for the purpose of diluting emissions, which is quite unusual, or usually because holes or gaps are present in the ducting. More commonly, though, additional air is added to the combustion process itself, usually because of poor boiler operation. Remember that in combustion, one does not want to add more air for combustion than the ideal amount, because this means that heat is carried out of the boiler and wasted. When air close to the ideal amount is passed through the boiler, the oxygen concentration downstream of combustion will be about 10%. If 10% is inserted into the equation, the oxygen reference factor becomes 1 and the emissions are not changed when multiplied by this factor. When additional air is passed through the system, the oxygen concentration will be higher than 10% and the emissions will be diluted by this extra air. If, for example, we insert a higher measured oxygen concentration of 18%, the factor becomes 3.67, higher than 1, and so when you multiply the emissions by this factor, they're going to become higher and therefore compensate for the dilution effect. So the dilution effect is corrected, and that is the purpose of oxygen references and why they're so important. It's to reverse the effect of dilution. As I have mentioned, oxygen references can only work for combustion where oxygen is consumed. If no combustion occurs and no oxygen is consumed, the oxygen concentration will remain at an ambient level of 21%, and if we insert this into the formula, the denominator becomes 0 and the equation becomes undefined. Let's move on to the other provisions in Section 4. Section 4 also states that emissions measurements must be conducted in accordance with the methods listed in Annexures A, B, and C. Annexure A specifies ISO methods, Annexure B specifies the US EPA methods, which are the most commonly used methods, and Annexure C specifies the BSEN methods. These annexures are the same as those which were specified in the South African Namakwa Listed Activities legislation, which was promulgated in Government Notice 893 in 2013. These were updated in 2018 with a more comprehensive, better ordered list, and it would have been preferable to include the more recent list in the Botswanan standard. This is just one of the instances where we find the South African legislation used in the Botswanan standard. In Annexure B, I've highlighted the most commonly used methods for emissions testing, and I did note that one method is missing, and that is the emissions testing method for ammonia, EPA CTM 27. And ammonia is one of the pollutants which is required to be tested by a few industries, as you'll see later in this video. Another provision in Section 4 is that when continuous emissions testing monitoring is done, a daily average must be reported and 80% of the values must be valid. Calibration must also be conducted at regular intervals, and this provision is similar to those which are contained in the South African legislation for continuous emissions monitoring. For periodic emissions monitoring, annual emissions testing must be done, and when testing is done, the plant must be operating at normal operating conditions. These are both features also present in the South African Listed Activities legislation. Stack testing must be conducted by a person with a chemistry background or equivalent, or basic training in stack testing. The standard then says that tests, which I assume means the laboratory analysis of samples collected during emissions testing, must be conducted by a technical signatory with a minimum of a certificate in chemistry or equivalent and 2 years' experience in a lab work standard practice. Lastly, results will be verified by the regulating authority at least once every 2 years. In terms of what the emissions report must contain, it must contain an APPRC reference number, although it does note that this doesn't apply in the initial registration report, so I assume that this number will be given once the first emissions report has been submitted. The reports must also contain the name and address of the stack testing company, the date and time of the tests, a declaration of normal operating conditions, the volumetric and mass flow data, which must be reported as an average of 3 measurements, and the pollutant concentration, which must also be reported as the average of 3 measurements with a minimum of 1 hour and a maximum of 8 hours per test. And then lastly, the methods which have been used must also be included in the report. A general special arrangement is that a fugitive emissions management plan must be included in the annual emissions report for activities which are likely to generate fugitive emissions, which is an interesting addition to the standard. The final section of the standard, Section 5, details the emissions limits. As I've mentioned, many parts of the standard mirror the South African listed activities legislation, and this is also the case for the actual emissions limits. What I've done is I've mapped the tables in the Botswanan standard with the corresponding subcategory in the listed activities legislation. The listed activities legislation contains 66 different subcategories, and the BOB standard does not use all of these, most likely because these industries don't exist in Botswana. You'll see that the listed activities legislation has 2 sets of emissions limits, new and existing emissions limits, and existing emissions limits were only applicable until the 1st of April 2020 and no longer apply, so it makes sense that these existing limits haven't been used in the Botswanan standards and only the new emissions limits have been used. Table 1 is applicable to solid fuel combustion installations, and the corresponding listed activity is subcategory 1.1. Although the same emissions limits have been specified, there is no threshold for combustion installations in Botswana to comply with these limits. In South Africa, these emissions limits are only applicable to very large combustion installations, which are bigger than 50 megawatts net heat input. So that's the kind of size of large power stations and sugar mill boilers. Also, as we've discussed, the Botswanan standard contains no oxygen reference, whereas a 10% oxygen reference has been specified in the listed activities legislation for subcategory 1.1, which is typical for coal-fired installations. Moving on to Table 2 in the Botswanan standard, it specifies limits for liquid fuel combustion installations, and this corresponds to subcategory 1.2 in the listed activities legislation. Once again, in the Botswanan standard, there is no threshold, so all boilers have to comply with these limits, presumably, and there is also no oxygen reference, whereas the South African listed activities legislation specifies an oxygen reference of 3% for subcategory 1.2, which is typical for liquid fuel combustion installations. Table 3 of the Botswanan standard applies to solid biomass combustion installations, and this matches subcategory 1.3 of the listed activities legislation. Once again, no threshold or oxygen reference are specified in the Botswanan standard. Table 4 applies to gas combustion installations, and it corresponds with subcategory 1.4 of the South African listed activities legislation. Again, no threshold and no oxygen reference are applicable to the Botswanan standard. Table 5 applies to reciprocating engines, and once again is the same as the listed activities, barring the exclusion of the threshold and the oxygen reference. Table 6, and we've now changed industries, so we're now in the petroleum industry. Table 6 applies to refinery furnaces and heaters and is the same as the South African legislation, and there's no threshold in either the Botswanan standard or in the listed activities legislation, but the listed activities legislation does have an oxygen reference of 10%, which is not applicable to the Botswanan standard. Table 7 is sulfur recovery units, and this matches subcategory 2.3, Once again, there's no threshold for either of these, but there is an oxygen reference applicable to the South African subcategory 2.3. Table 8 applies to petroleum product storage tank and product transfer facilities, and it matches subcategory 2.4 in the listed activities legislation. There is a difference here. So the difference is that where the South African legislation has an emissions limit of 40,000 milligrams per normal cubic meter for TVOCs, the Botswanan standard only has a limit of 4,000. I'm not sure if this was a typo and a 0 was left off, or this was intentional. A limit of 40,000 is particularly high, and so it may have been intentional to reduce the emissions limit to 4,000. Table 9 is applicable to industrial fuel oil recyclers, and it corresponds to subcategory 2.5 in the listed activities legislation. This table matches subcategory 2.5 exactly, so it specifies the same thresholds and neither have an oxygen reference, and the emissions limits are the same. Table 10 applies to tar processes, and it is equivalent to subcategory 3.3. These two tables are the same as well, and the emissions limits match. There's no threshold in either, and there's no oxygen reference for either. Okay, table 11, once again we have moved industries now, so we're in the metallurgical industry, and table 11 applies to the drying and calcining of mineral solids, and it's equivalent to subcategory 4.1 in the listed activities legislation. And both tables have a threshold of 100 tons per month, and neither have an oxygen reference. But we can see that the Botswanan standard doesn't include emissions limits for NOx, where the South African legislation does. Once again, I'm not sure whether this was a mistake or if this was intentional and NOx was left out for a reason. So once again, another question that I would like to address with somebody who was involved in the creation of this Botswanan standard. Table 12 applies to sinter plant, corresponds to subcategory 4.5. These subcategories and the subcategory in the table match exactly. There are no oxygen references and there are no thresholds for either, and the emissions limits are the same for both. Table 13 is limits for basic oxygen furnaces, and it matches subcategory 4.6. These tables are the same, so there is no threshold, and both are applicable to all installations, and there are no oxygen references, and then also the emissions limits are the same. Table 14 is applicable to iron ore, steel, or ferroalloy production and casting, and it is equivalent to subcategory 4.9. So interestingly, in this table, the SO2 emissions limit in the Botswanan standard is slightly stricter at 400 milligrams per normal cubic meter instead of the 500, which is in the listed activities legislation. And then you'll also note that in the listed activities legislation, there are 3 different sets of emissions limits for particulate matter, depending on the specific ferroalloy production that is being done. In the Botswanan standard, just one of these has been chosen. So the first one, which in the listed activities is applicable to open and semi-closed furnaces, this one has been used in the Botswanan standard. Otherwise, they are the same. No oxygen reference is applicable to either, and there is no threshold for either tables. Table 15 applies to the use extraction of lead. What's interesting here is that an additional emissions limit for HCl, hydrochloric acid, has been added to the Botswanan standard, and this wasn't present in subcategory 4.13 for 4.13, which is the corresponding listed activity. So there's the additional HCl emissions limits. The emissions limits for particulate matter and for lead are the same. There is a threshold of 20 kilograms per month for the South African legislation, and this doesn't apply for Table 15. There's no threshold, and there's no oxygen reference for either of these tables. Table 16 is applicable to the extraction, processing, and production of nickel, and it is equivalent to subcategory 4.14 in the listed activities legislation. Interestingly, in the Botswanan standard, an additional limit for particulate matter has been added at the bottom of the table, and this is not present in the South African legislation. It's assumed that this was a typo and wasn't meant to be there. There is an oxygen reference for the South African legislation, which isn't applicable in the Botswanan standard, and there are no thresholds for either of the tables. Table 17 is applicable to the production or processing of precious and it is equivalent to subcategory 4.17 in the listed activities legislation. These tables show the same emissions limit and the same pollutants which are required to be tested, and neither have a threshold. Table 18 is applicable to the recovery of metal from any form of scrap metal, and it corresponds to subcategory 4.21 from the listed activities legislation. So both of these tables there's no threshold, so they are applicable to all installations, and there's no oxygen reference for either, except in the South African listed activities legislation there is a 10% oxygen reference for dioxins and furans, which is quite curious. This isn't applicable to the Botswanan standard. Most interestingly, however, you will see that emissions limits for particulate matter, for carbon monoxide, for sulfur dioxide, and for the oxides of nitrogen have not been included in the Botswanan standard. So this is also definitely a question I want to pose to somebody who was involved in the creation of this standard. I can't imagine that it would have been intentional, and I imagine that it would have been a typo or they would have been left out by mistake, but it will be good to clarify that. And we'll see that the same occurs in table 25 later in this video. Table 19 is applicable to the drying of mineral solids. So there are thresholds for both tables. There's a threshold for the Botswanan standard and for subcategory 5.2 of the listed activities legislation, which is the corresponding subcategory for this table. There are no oxygen references for either, and the same emissions limits are applicable. Table 20 is applicable to clamp kilns for brick production, and it corresponds to subcategory 5.3 in the listed activities legislation. There is no threshold in the standard, but there is a threshold of 10,000 bricks per month in the listed activities legislation. The same pollutants are required to be tested, except dust fall, which is referred to in the listed activities legislation is referred to as particulate matter in the Botswanan standard, but they are essentially the same. Sulfur dioxide, SO2, is also there. And in the South African listed activities legislation, they don't actually put the emissions limits in the table itself, but there are special arrangements which are included at the bottom of the table. In the Botswanan standard, these numbers have just been included in the table, which makes sense, but you will see that they are actually in microgram per cubic meter, and the reason for this is because these are ambient pollutant emissions. Clamp kilns don't have a dedicated stack, and you can't actually conduct stack emissions testing on a clamp kiln. What you have to do is you have to do ambient emissions testing in the vicinity of the clamp kiln, and that's why the units of micrograms per cubic meter have been used. So there's a limit there of 200 for PM10 and 350 for sulfur dioxide. Table 21 is applicable to cement production. So this is quite interesting. Table 21 is equivalent to subcategory 5.5 in the listed activities legislation, but subcategory 5.5 is only applicable to cement production when alternative fuels or resources are used. Alternative fuels would include waste tires or other kinds of waste, which is burnt in the kiln instead of your conventional fuels like coal. So when alternative fuels or resources are used, this long list of pollutants is required to be tested. And the reason for that is because waste is being burned and dangerous pollutants could be emitted from waste, and you're required to test all of them. In the Botswanan standard, this long list of pollutants appears to have been applied to all cement production facilities, to all cement kilns. So this is interesting because you wouldn't necessarily expect all of these pollutants to be emitted in large quantities from cement kilns using a conventional fuel like coal. It's possible that all of the cement kilns in Botswana use alternative fuels, although I think it's quite unlikely. So once again, definitely something that'll be interesting to chat through with somebody who created or was involved in creating this standard. Table 22 is applicable to ceramic production, and it's equivalent to subcategory 5.9 of the listed activities legislation. Ceramic production is applicable to other brick kilns which aren't clamp kilns. So there are other ways that you can make bricks, not only in clamp kilns, and these kilns would then fall under this table or this subcategory if you're in South Africa. So there is a threshold in both of these tables of 100 tons per annum, and there is no oxygen reference applicable to either, and the same emissions limits have been used in both. Table 23 is applicable to macadam preparation. Macadam is basically tar that you use on roads. It's equivalent to subcategory 5.10 in the South African legislation. In both, there is no threshold. They're applicable to all facilities, and neither have an oxygen reference, and the same emissions limits have been used. Table 24 applies to the production of acids, and it is equivalent to subcategory 7.2 in the listed activities legislation. So something that I did notice here is that the HCl emissions limit from primary production is stricter in the Botswanan standard at 5 milligrams per normal cubic meter than South Africa's 15 milligrams per normal cubic meter. Neither tables are subject to an oxygen reference, and there are thresholds which are applicable to both of these tables. Table 25 is applicable to the thermal treatment of general and hazardous waste. So a good example of something that would fall under Table 25 would be the incineration of medical waste. This table is equivalent to subcategory 8.1 in the South African legislation. And like we already discussed, I think it was in Table 18, emissions limits for particulate matter, for carbon monoxide, sulfur dioxide, and the oxides of nitrogen have been left out. So, as I mentioned, that's definitely a very interesting change, and I would love to hear the reasoning behind it if it wasn't just a mistake. There's no threshold which is applicable to the Botswanan standard, but there is a threshold for the South African subcategory, which is pretty low at only 10 kilograms per day of waste. And the South African subcategory does have a 10% oxygen reference, which is applicable. It's actually not noted in the table, but it's noted in special arrangements underneath the table. And of course, the Botswanan standard doesn't have any oxygen references, as we know. Table 26 is applicable to crematoria and veterinary waste incineration. So this is another very interesting one. The South African subcategory 8.2 is the equivalent subcategory, and you can see emissions limits are specified for particulate matter, for carbon monoxide, for the oxides of nitrogen, and for mercury. In the Botswanan standard, particulate matter, carbon monoxide and sulfur dioxide emissions limits have been specified, which are different to the South African legislation, and then particulate matter and carbon monoxide are repeated again. One would definitely expect mercury to be included in a table that is applicable to crematoria, because mercury is present in amalgam fillings, and if those are present in the bodies which are burned, mercury will be emitted, and mercury is a big environmental concern. So it is curious that mercury has not been included here. Another question to ask. Oxygen references, so nothing is specified for the Botswanan standard, as we'd expect, whereas an oxygen reference of 11% is applicable to subcategory 8.2, and there are no thresholds for either of the tables. The last table is table 27, and this is applicable to causticizing processes in the pulp and paper industry. And this table is the same as the South African, as in the South African legislation in subcategory 9.1, except for the fact that there is no oxygen reference. Both tables have the same emissions limits for the same pollutants, and they have the same threshold of 1 ton per month. So those are all of the tables in the Botswanan standards. We've discussed the questions which I have gone through. The first one being the legal status of the Botswanan standard and whether there are sanctions for non-compliance with the standard. Another relevant question here is whether there are time frames for compliance. When the South African listed activities legislation was promulgated, there were a number of time periods and grace periods that were provided for in the legislation, and this makes sense because it gives companies time to upgrade their plants so that they can comply with emissions limits. Another big question mark for me are the lack of oxygen references. Oxygen references are a really useful tool when you are comparing combustion installations because they allow you to compare on a like-for-like basis without the effect of dilution by ambient air. So that's really important and really interesting that they explicitly haven't been included in the Botswanan standard. And then, of course, as we went through all of the tables in the Botswanan standard, there were a number of anomalies. So some made sense, like the addition of HCl in one of the tables, and others didn't make sense, like randomly leaving out PM, CO, SO2, and NOx in the hazardous waste table. So yeah, there are a number of questions that I would like to pose to somebody who helped with the creation of this Botswanan standard, and I do hope to update this video as soon as I have some answers. I hope that everybody enjoyed this video and found it informative. If you have any questions that I didn't address or I didn't pick up in this video, please feel free to send them to me, and my contact details are included below, and I would love to hear from you. Thank you so much.